So my project is on the Ceratopsian brain case anatomy and paleoneurology. So Ceratopsians have been in the media a lot recently because some fantastic specimens have been uncovered, including the little Psittacosaur with the fantastic quills up its tail, and that's really changed how we reconstruct Ceratopsians. These are quite extreme reconstructions, but I really enjoy the kind of porcupine-esque Ceratopsian little Psittacosaur on the left there, and the Mark Whitten's fluffy Pachyrhinosaur on the right. So my project, basically, it hinges around some 3D reconstructions. So I go to institutions. I went to China last year, and I collect some CT scans. I then reconstruct these in the brain cases of these skulls in a viso, and then make some detailed descriptions and create some 3D PDFs so that it's accessible to everyone. I'm doing this through ontogeny, so I collected an ontogenetic range of Psittacosaur skulls from China, so that's there. And then, as my project evolves, hopefully, so will the evolution of Ceratopsia in this case, and I will collect skulls through the evolution. My project also includes some phylogenetics and macroevolutionary aspects, but I have not got time to talk about that. So why have I picked Ceratopsia? Well, they are one of the most diverse and common dinosaurs in the upper Cretaceous strata of America, and have a fantastic range in China as well. And as you can see here, by the end of the Maastrichtian, around 30% of dinosaur occurrences are Ceratopsians, just in what we have, in what we found. They're also a group for which a lot of behavioural traits have been posited, so such as the gregarious behaviour of centrosaurines in North America. And we have fantastic ontogenetic series for a lot of groups, which is quite rare in vertebrate paleontology, particularly dinosaurs. We recently also have a baby Chasmosaur and a baby Pentaceratops as well. It's also a group for which a postural shift can be seen throughout the evolution of the clade, and in some cases it's been posited that there's a postural shift in individual taxa, such as Psittacosaurus, and that's something that I'm working on quite closely. Sampson noted that there are two separate groups of Ceratopsians in North America, and he thought that there might be some interesting endemism there, and it would be really great to see if this is true and if there is any evidence for that in the paleoneurology of these beasts. So here are some really rough endocasts that I've done. The top one is a Albertoceratops, and the bottom one is a Hongshanosaurus endocast. So the blue areas are the brain cavity where the brain would sit, the yellow is the nerve pathways, and the pink are the semicircular canals. From these structures, from the morphology of these structures, we hope to find out something about the sensory abilities and whether there's any evidence for the complex social behaviour that has been theorised previously. Also, the semicircular canals have the ability to identify the posture, which is something that I'm working very closely on, and very debated, the cranial orientation. So this is an example of my Hongshanosaurus skull. So as you can see, I've segmented out the brain case and all the different bones there. And I'm currently working on this for the ontogenetic series of Psittacosaurs from China, and then later on I will be going to America to collect, hopefully, an ontogenetic range of Protoceratops. Thanks for listening.